Okay, so what we would have done in class on Thursday, had we had class, was we would have remembered we have three equations to this point that you learned in grade 10 science. VAV equals delta D over delta T. A equals VF minus VI over delta T. And this one, which is maybe you didn't learn in grade 10 science, but it's kind of common sense, the average of any two things, you just add them together and divide by 2. So to this point in kinematics, these are the three equations that we have. But we've been looking at questions when we've been doing the graphing and drawing to scale, where we can't where we want to find the displacement when there's been an acceleration. Okay, so we were finding the area under the curve to do that with our velocity versus time graphs. But it's not always convenient to plot out a graph and find the area under the curve. So what we're going to do is come up with two new equations where we can find the distance traveled even if the object's accelerating. Okay, so that'll be our first one. Now there's two assumptions we make here. One is that the object's moving in straight lines, like forward and backward, east-west, or north-south, but they're not changing direction and going at right angles within the journey. Okay, that's for grade 12. And the other one is we assume that the acceleration within the particular question is constant. Okay, so what I'm going to show you is how we get these two equations. I will never ask you to regurgitate this. I just want you to understand that they come from the three equations we already know. So if we take our equation number 2 and we rearrange it for VF, we would multiply both sides by delta t, so to be A delta t is equal to VF minus VI, and then we could add VI to both sides. So it would be VI plus A delta t. And that's what our VF is equal to. So if we now take this value for VF, and if we sub it in to our equation number 3, so sub into 3, so our 3 is VF is equal to VI plus VF divided by 2. So where this VF is, we're going to sub this in. Okay, so it'll become VF is equal to VI, and then in place of the VF, we have VI plus A delta t, and then it's all divided by 2. Well, VI plus VI is just going to give us 2 VI, so we'll have 2 VI plus A delta t, and instead of it all over 2, we could write it like this, over 2 and over 2. So this would be our VF. Well, obviously, these two 2's will cancel. So we would have VF is equal to VI plus, and I could write this as 1/2 A delta t. Okay? But this VF up here in our first equation from grade 10, we know that VF is equal to delta D over delta t. So if VF is equal to delta D over delta t, and VAV is equal to VI plus, then these two things must be equal to each other. So we're going to set them equal to each other. So delta D over delta t is equal to VI plus 1/2 A delta t squared. Or excuse me, just delta t. Now I'm going to multiply both sides to get by delta t to get rid of it. So my equation will become delta D is equal to VI, multiply this by the delta t to get rid of it, plus 1/2 A, multiply this term by the delta t, and it becomes delta t squared. And this is my first equation. So it's on this sheet that I gave you the other day, right here. And so you should highlight it, you should star it, you should asterisk it, you should make like fireworks coming out of it. It is probably the most important kinematics equation. By Monday, I want you to be able to say, without looking at it, delta D is equal to VI delta t plus 1/2 A delta t squared. You should be able to say it like backwards while standing on your head, humming O Canada in Swahili at the same time. It should interfere with your alphabet, that you'll start doing A, B, C, D, but when you get to D, you'll go delta D is equal to VI delta t plus 1/2 A delta t squared, so that never again shall the alphabet be the same. Okay, so that's our first one. And it's finding distance or displacement when there's a constant acceleration. All right, and we'll do a couple examples in the next video using it. The second equation we're going to find is going to be for final velocity when we don't have time. So if we go back to where a equals vf minus vi over delta t, and we rearrange this for time, so it'll be t is equal to vf minus vi over a. We're now going to take this and sub it into our new guy. So everywhere delta t is, we're going to put in vf minus vi over a. And again over here, 1/2 a vf minus vi over a, only this one gets squared. Okay, so we'll have delta t is equal to, well, vi times vf, so vi vf, vi times vi, so minus vi squared, and that's all over a. And then here, plus 1/2 a. And now we have to square vf minus vi, vf minus vi. So we have to FOIL it. We have to do it out. And on the bottom, it'll be a squared. Okay, so it'll be delta t is equal to vf minus vi, vf times vi minus vi squared over a. We'll just leave that term for now. Plus 1/2. Now this a should cancel out with that a squared. So on the bottom, there'll just be an a now. Vf times vf will be vf squared. Vf times vi minus vf vi. Vi times vf minus vf vi, again, doesn't matter the order there. And negative vi and vi, so plus vi squared. Okay, and there's a bracket here. So let's get rid of this a that's on the bottom. Let's pull it up here. So it'll be a delta d is equal to, so now I have vi vf minus vi squared, and now we have to multiply through by the 1/2. So plus 1/2 vf squared minus vf vi minus vf vi will be 2 vf vi, so negative 1/2 times 2 vf vi, so that should just be like vf vi because those are going to cancel, plus 1/2 vi squared. Well, I have a vi vf here and a vi vf here, so those disappear. Negative vi squared plus 1/2 vi squared. Well, let's multiply everything by 2 to make this easy. So it'll be 2a delta d is equal to negative 2 vi squared, and then plus vf squared minus, multiply this by 2 vi squared. That should be easier to see. Oh, except that's a plus. It'd be easier to see. Here we go, plus. So this should leave me with 2a delta d is equal to negative vi squared plus vf squared. And we said we were looking for the equation for vf. So let's take the negative vi over where it'll become positive. So it'll be vi squared plus 2a delta d. Vi squared plus 2a delta d is equal to vf squared, but I don't like my unknown on this side, so I have to take it over here. So vf squared is equal to, and this is our second equation. We don't usually write the square root sign in it, because lots of times you have to rearrange to find a or to find delta d. So it's vf squared is equal to vi squared plus 2a delta d. Star it, put fireworks around it, highlight it, okay? Because this one too you need to know off by heart, able to say it backwards, forwards, while standing on your head humming O Canada in Swahili. Okay, so we now have 5 equations. We still can use these 3 up here. Probably the one you'll use most of these 3 is a equals vf minus vi over delta t. And then this is equation number 4, and this is equation number 5. So probably the 2nd, 4th, and 5th will be the 3 that you'll use the most. And the second, the last one there I just derived is on the bottom of this sheet. So in the next video, we're going to do the back side of that sheet, which has 3 examples on it. So I'll show you how to use those equations. Okay, so in 2 seconds, we'll start here because my video is just about to stop.